I believe it's item number 5. Then photovoltaic cells. Photovoltaic cells, whatever referred to as the solar cells. We all have heard of this, and where we apply them particularly in our lighting system, particularly in our homes. We have the solar cells and the solar panels where they're used. So we want to understand how does these solar panels work. So we are also going to talk about the construction of it and the symbol. Anytime we talk of this, you need to understand how does the symbol appear. So this is the symbol of the solar cell. And in this case, there are no lights drawn on it. Take note, there are no lights drawn on it. And also we have to have the basic construction of how this solar cell looks like, so that when we are explaining it, it becomes very easy. So this what happens. This is what referred to as the construction diagram. So when you look at this diagram, there's incident light, and what normally happens with the solar panels or with the solar cells is that the surface layer, whatever referred to as the glass or the surface layer for protection, is very thin, so that light can easily penetrate all through to the PN junction. Once the light reaches the PN junction, the PN junction is eliminated, and the cells becomes active. When the cells become active, they regenerate the process, and when we connect the terminals, we connect the conductors across the battery or across the terminals, then we shall see the current flowing if you connect the ammeter. So sometimes we'll be asked they'll draw these diagrams in a circuit and ask to explain. Once you identify the device, then you explain for the concept of the operation of the device. It becomes very easy, and for you to really understand the circuit very fast. Identify the component, and I know the principle through which it works. For this case, the light has to come through the glass all the way to the PN junction, and the PN junction will be able to give us some energy when the terminals are connected. Then we talk of the construction part of it. How does the solar what makes the solar cell? Then it consists of an N. It consists of an N-type material. And a P-type material. Because if an N-type and P-type material that actually brought together to form a PN, together to form a PN junction. So when you see that, then we shall be able to see what happens. So the upper surface is made of glass, which is the upper surface is made of glass, of a very thin layer, to allow easy penetration of light. To the PN with penetration of light to the PN junction. Then we're going now to discuss the operation of that. So operation, we're starting on the operation so that we understand what happens. So whatever, when the PN junction of the solar cell is eliminated, electron hole pairs are generated. So when this light reaches on the PN junction, we generate electron hole pairs. So the first statement we have is that when the PN junction is illuminated, by the incident light, illuminated by the incident light, electron hole pairs are generated. And electron hole pairs are generated. Electron hole pairs are generated, and electric field is established. And an electric field is established. Electric field is established across the terminals or near the PN junction. Electric field is established near the PN junction. Near the PN junction. So these hole pairs, electron hole pairs, are normally positive and negative ions that we normally have. So since the number of pairs exceeds the number of thermal equilibrium, since the number of electron hole pairs exceeds the equilibrium, required for balance, then electrons will flow, or the electric field, electrons will flow towards the terminals. Electrons will flow towards the terminals. And if the load is connected, it will constitute the current flow. It will constitute the current flow. So whatever you need to understand is that the approximate size of each cell is 1.5 volts, and for us to increase the capacity of the panels, then there's a way in which we are supposed to be connecting them. Then in this case, so let us take note that for more voltage, generation, the cells are connected in series. The cells are connected in series. And for greater current, the cells are connected in parallel. In this case, I mean that if you want to connect the cells, we shall connect them this way. Then these are the individual cells that we have. So these cells will be 1.5 volts, 1.5 volts, 1.5 volts, all the way to the standard, so that by the end of this process, we shall have what I refer to as, by the end of this process, I shall have what I refer as 12 volts. Then if you need to increase the amount of current for the solar panel, then you have to have parallel cells that of 1.0 volts, 1.0 volts is. So for us to increase the current in the panel, then we shall have another cell that also appeared of that. So these are cells. So we shall be able to have this as the connection way for us to get the greater voltage. So in this case, we shall have, of course, the cells in the series are 12 volts. And those 12 volts are connected in parallel. We shall now have a greater output current here that shall be going maybe out to our battery now, so that we can now talk of the supply or the charge being there. So we're going to do the application and advantages of these solar cells. So once again, I remind you that we need also to check on our uploads, and particularly for the issue of confirmation and getting more of the other applications that we are not stating here. So we shall have advantages first before we state the application. Advantages of advantages. So number one is fair efficiency. And number two, we have unlimited life. Unlimited life. We see so many people using solar nowadays, and because once installed, by the time they think of even moving out, so many years have rolled. So we talk of the unlimited life. And number three, we also talk of they're easily mass produced. Easily mass produced. There is easily mass production. There should be easy mass production. Easy mass production. Easy mass production. Easy mass production. And maybe my final application will be high power capacity. So this a bit of the application of these, application of solar cells. We particularly use them in solar panels. Solar panels. We are now going to cover our next one, which is a phototransistor. So phototransistor, the principle also, we also would have to draw the diagram first. This is just a normal transistor, but it's a two-terminal thing. It's not a three-terminal. So we shall have light incident on the base. We shall have light incident on the base. So we also this is the diagram we're expected to know concerning the phototransistor. So this is normal base. This is the normal collector, and this is the normal emitter. So we can have this as this direction. So this is a symbol of a transistor, but in this case, there's something appears on the base, which we talk of this as the light. So that becomes photo, because light is incident to the base. So the principle of switching of operation is that the light must be incident to the base. And you know, from the preparation of a normal transistor is that we must have the bias current at the base. So that bias current which is required will be provided by the incident light. So in this case, this is just, it is a light-sensitive transistor. That's it. It's a light-sensitive transistor. It's a light-sensitive transistor and is similar to an ordinary transistor. And it's similar to an ordinary transistor. Ordinary transistor, in this case, I'm referring to as the bipolar transistor. Bipolar transistors. That's what I'm saying, I refer to as the ordinary transistor. But it has no connection at the base. But there is no connection at the base. Then how does it operate? We go to the operation. When we go to the operation, so when light is incident on the base emitter junction, when light is incident on the base collector junction, when light is incident, on the base collector junction, it's incident on the base collector junction, small current generated, small current is generated depending on the intensity of the light. Depending on the intensity of the light. So another thing you need to know is that when this light is generated, when it becomes greater enough to overcome the barrier potential or the potential required across the base collector junction, the transistor is going to turn on. So we'll proceed, Dogo. So this statement, when the current grows to a greater value, the current grows to a greater value, the transistor will be turned on. Will be turned on depending on the intensity of the light falling on the base. So therefore, from this, you can be able to have the characteristic of this. So we shall have some characteristics of this. So this is, we're talking of the lumen. This is VCC, and this is current. So this is lumens. So this is how the characteristic appears to be like. So it becomes very easy so that you understand that this is the light intensity. So when light increases, we're increasing the current across the junction. So from there, just go to applications and advantages of this photoresistor. So we talk of the advantages before we go to the application. Advantages. Number one is greater sensitivity than photoresistor. Greater sensitivity. Greater sensitivity than photodiodes. Photodiodes. Another application we have here is the high current capacity. Another advantage is high current capacity. High current capacity. Then we go to the applications now. So number one is the photo detection. Number two is the logic circuits. Number three is switching. Number four is the optical communication. There's so many that are normally repeated. Optical communication. Number five, we're talking of the demodulation circuits. Demodulation. Circuits. And lastly, number six, I cannot write everything. And we shall discuss anything. We'll talk of the encoders also. So I've reminded you that look at our notes on the website. You'll be able to have addition of this. So we're going to the seventh device, which is the optocouplers. Optocouplers. So this is optocoupler. So from just the subtitle we have here is Opto. And this case we're coupling two devices that are optoelectronics to work as a single unit. So I'll be able to sketch some of the how they appear so that you're able to see these are the devices I've done. So I'll be able to sketch this so that we have at least an idea of what is there. You can also have other devices that could couple this. Maybe another example of an optocoupler. So from these two diagrams, we are going to realize this is a light emitting diode and this is a phototransistor. And from this case, it's a light emitting diode and this is a photodiode. So the two devices that already studied have been coupled and they're able to work as a unit. So for us, when we connect our circuit or the operational circuit that we want to control on the output terminals, which I still have with me here. On the output terminals, that's what we're going to connect to the circuit we want to control, while the switching part of it, or while the input part of it, controls this. So at the end of this process, we're able to control the circuit. So it's referred to as an optocoupler. So how then does it operate? Then when we want to control a circuit, we connect our control circuit or the circuit of operation on the output terminals, but we connect the input signal to we connect the signal at the input terminals so that our input signal is able to turn on. So normally this is connected between two circuits to provide isolation. And particularly when you observe like our TVs, this is what happens when we turn on and we see the TV going to the standby as an example of that. So by the time you press your remote, then you are activating the LED so that we're able to switch on the optocoupler to emit light to complete the circuit. So particularly, this is just an isolation circuit. So it consists of an LED and a light detecting device, e.g. a photodiode, e.g. a photodiode, or a photoresistor, a phototransistor or a phototransistor. So its main purpose is isolation of electrical circuits, particularly for transit surges, isolation of electrical cells, particularly where there are transients, surges, etc. Then we are going to the last device in this application that we have here. We're going to the last device. So let me just give you some map of the applications here before we proceed. Applications. Number one, maybe electronic devices. Let me just use electronic devices. Electronic devices. But what I refer to as switching circuits, and lastly maybe I refer to as surge protection. So those are examples of applications that we have. But basically these are things we have done in the previous lessons that we have been doing. So we are going to have the final circuit, which I will talk as Ruby Lesser. So our last component is the Ruby Lesser. Ruby Lesser. So we're going to have a diagram first before we proceed. So we can discuss this. So look at this. This consists of two mirrors, totally reflecting mirror and a partially reflecting mirror, and a xenon tube. Xenon tube actually for generating the electrons. So we're talking about the construction. And we said it consists of a ruby rod with two mirrors. With two mirrors, one is totally reflecting, while the other is partially reflecting. It's partially reflecting. So you go to the operation. Talk of the operation. So when xenon tube is ignited, chromium atoms are generated. Chromium atoms are generated, and when they are generated in the ruby rod, are generated in the ruby rod, and they're generated in the ruby rod, and therefore the flash of light is absorbed, and therefore the flash of light is absorbed of the phasors from the back, is absorbed of the phasors from the back, phasors from the back of the tube, from the back of the tube. So one thing, we are going to try to ignite the ruby laser, and it starts budding, and it's going to generate whatever referred to as chromium atoms or photons, and this light will absorb from the back. So they'll be reflected back forth to the forward direction towards the partial mirror. So another thing, when the chromium atoms falls off, when the chromium atoms falls off, they fall off, they produce spontaneous, they produce whatever to spontaneous emissions. In fact, these are what are referred to as the photons on the surface, and these are reflected by the totally reflecting mirror, towards the partially reflecting mirror. Towards a partially reflecting mirror. So therefore, light is illuminated at the output of the partial mirror. So this is what we need to know concerning the chromium atoms. So the only thing I can now need to know is to maybe an application of this. Can I use an application of this? I can now know is the application. The application of this, you can use this as optical cavities. Cavities, so particularly in medical, whatever is medical industry. Cavities treatment.